Hello everyone, my name is Thảo. On behalf of our team, Sealid, I would like to warmly welcome our lecturer and the co-representative to our final project presentation. We truly honored to have Cole here today with us. Our project focuses on transforming existing ceiling camera into the smart sensor that monitors cell stock using AI. This is my team member and the QR code for GitHub repository. My team member Huy now will show you how to build the project.
Okay, so I'm gonna show you how to build a project from the start and from using Docker and from our GitHub and by following the README file. Uh, when you scan to this QR code, you can easily access to our repository and we'll follow the README file here to clone our GitHub repository. So you can see clone the repo by using git clone, and I will go to the Visual Studio Code and open the terminal and then using git clone. So this will be cloning the whole project, and also it will clone the submodule, which is our front end and our back end, and connect together. As you can see, we already cloned it, and then I will follow the next command by moving into that folder. After moving to that folder, I'm gonna build the image by using the command docker composer. Okay, so this image will took a lot of time to build, and because this I already built it in my computer, so it will save more time. But if you build from the first time, it will took about 15 to 20 minutes to build the whole image from the back end, front end, and the R model. And yeah, now we'll continue our presentation by getting back to Thảo.
So let's start by looking at the problem we set out to solve. In most supermarkets, cell level visibility is still manual process. Ceiling camera is mainly used for security, not for cell analysis. This leads to three key issues. Firstly, manual checks is time-consuming and inconsistent, which means are often missed. Secondly, stock storage are usually detected too late. And lastly, there is no per product, so it's hard to trigger timely replenishment. Now moving to the next slide, project motivation. Call is exploring AI to improve operational and customer experience. Our motivation is unlock value from camera already in play, turn them into the smart cell monitor. With the AI, the system can automatically track the shell level, reduce manual labor, and improve the on-cell availability. This is especially important in an area like fresh fruit, where stock change very quickly. To address the problem, we define four main goals. Firstly, build an AI engine to estimate the shell fill percent from ceiling camera. Secondly, develop the dashboard to display the result notification to the staff and the report. Nextly, evaluate the multiple AI model to make sure the percent of accuracy and scalability. Lastly, deliver the complete end-to-end system with documentation and the working demo. Now let's take a look with the technical side, the functional requirement. Let's make on this possible. Based on the silent discussion and quickly feedback, we finalize the following functional requirements. Firstly, detect and segment shell atoms to calculate field density. Secondly, estimate field price percentage and send the notification to the step when it's below 20%. Next, real-time notification with countdown and priority ranking to avoid notification overload. In addition to interactive dashboard, like filter by the store product, the report or check KPI. Moreover, the security and asset control we We will build the role-based permission for manager staff aligned with core data policy. In conclusion, the main idea is 20% limit, less than 5 minutes in response time, and fresh food prioritization.
So now I will move to the solution overview of the our project. So with this project, our solution is just from codes using the steering camera to provide the self image or the video, and just capture from those images. We will use apply some AI model by using SAM. It means SAM2. It means segment anything model, and this is the second version of Facebook research. So from Facebook developer, and also we will going to use the meters from the interrupt for the depth estimation, and the output will be the real-time stock level result for every product and display in the web dashboard, and it will be help the staff quickly identify which cells need to be restocking, and also you can view it and export it into the table or the image. And exactly our goal is to support the staff with the accuracy and real-time cell visibility for our stock level. And this is the flow chart from from our system. So the image will be captured from the camera, or you can and current at the moment we're using the web page. So you must insert your image, and then it will from the front end, and will be passed to the ASP.NET for control the flow, and we pass to the AI model, and AI model will do the segmentation, which is says SAM2 and depth image turn from meters, and then the final product will be the dashboard. Now we're gonna move to the vision of our model. So our vision is to create an automated system, intelligent system that can transform every self-image into the precise stock insights. And as you can see in an image, each product type like apple, bananas, or broccoli, this is just our prototyping, will get the detection, and then it will be analyzed for detect every percentage for each status, and it will estimate how full each shelf session is, and displaying the percentage of remaining stock. And this makes much easier for staff to see when an item is running low, and with the menu scanning the shelf. And yeah, you can also view in the table view, because this will help the staff to verify the accuracy of our AI models as well. And then this is our AI design and research to this problem. So as you can see, from the left side is the formula, which will be demonstrate the algorithm how AI working, and this is the formula by to detect how many the pixels from the mask and the total pixel from the segmentation detection for of each product. And then from our product, we're gonna do the field pixel divided by the total pixel to get the percentage. So this will be the right hand side will be how the formula performs to you guys. So from the first step, segmentation will be used to identify which pixel belong to each product or subregion. And the second step will be the depth estimation to see how far each image from the camera depth, because this is the from the steering camera. So our problem is because the farther the nearer camera, the nearer product will be detect easier. So we need to use the depth estimator to identify the farther product as well, and also the system check to how many pixels inside each mask are close enough to count as field. And the last step, it will be the using this formula by divide the field pixel by total pixel to calculate the stock level for each product. And this will be the sample for our AI research. So from this original image, which is from our self camera, we will be performing using the depth estimation algorithm to see how depth is it from the nearest to farther camera. And the this one we want to do the segmentation. So we will create a mask for each cell product. So gonna be this mask gonna be the possible full self like full stock for that product area. And then we're gonna do the segmentation to calculate the percentage fill for each product of that. And then we will do the final analysis. This is gonna be the final analysis for ourselves by doing the segmentation to that specific mask. And to apply to our to this model to this system, we're gonna use this tool to help us to develop it. First of all, we're gonna use GitHub. Yeah, it's actually for version control and for team contribution for GitHub to code everything from start to the end. And we're using front end, we're using Next.js to easier. That's easier. That because it's use React. And next, we're gonna use Jira for task management and check everyone's progress. And go with Next.js. We're gonna use Figma for doing the UI prototyping, the front end use prototyping. Next, we're gonna use Docker to connect every field from the AI model to the front end to the back end. And also for ASP.NET to control the flow, to create the API for the back end and for the front end to create the API. And also we can expand to other field when we want to. For the fast API, this is the connector between the AI model and the backend server. And of course, our AI model using SAN2 and Midas. This is how it look like for the system architecture from end-to-end flow. So every of our server gonna be front-end server, the back-end server, and the AI model will be containerized by using Docker image. And then the AI model will run SAM for this SAM and Midas for segmentation and depth estimation to reduce the stock percentage of output. And the reason why we use Docker, because it will be ready for every build image and it will work for every computer. That's have the compatibility because you just clone the GitHub repository and run from Docker to see the front end run, the back end run, and the AI model running. And now we're gonna do to the user story and functionalities. This one is from Anna, who is missing from our team at the moment because she got a health problem. So let's go to our user story.
And in this video, I'll be demonstrating key user stories for AI stock level estimation project. These user stories will show how users interact with our system to upload images, view AI-generated stock analytics, and inspect detailed data in the table view. Alright, so from the home page, users can click on Get Started or the Upload button from the nav bar. Here, the user selects which camera the images came from, whether it's camera 1, 2, or 3. So for this example, I'll be choosing camera 2. I click Upload after choosing several shelf images from my computer, and you can see the preview grid appear immediately. This preview step is helpful because it lets me double check that every image is clear and correctly aligned before sending them to the system. So when I'm ready, I'll scroll down and click Upload Files. A progress bar appears while the files are sent to the server. Once the upload completes, the system confirms it was successful and gives me the option to go straight to the dashboard. And now we click View Dashboard and we will be taken to the dashboard page. So from here, we can see the products that the AI was able to detect. And we can click on Basil, for example, to see the stock level for each frame. And we can further inspect it by hovering towards the graph, and it will show you the percentage of the stock level. So we can actually select multiple products, and right now we'll just select mashed potatoes and brown onions. And when we scroll down, we are able to see the latest analysis result, which is the analysis results for the latest frame. And we can scroll back up, and by clicking clear all, it will clear the graph. By clicking select all, it will select all the products, which is very messy, so we will be clearing that. And now I'll be demonstrating how you can save the graph. So click a few products, for example, and we'll save it as PDF. And so here is the saved graph in PDF format. For the next user story, we will be clicking on the table view. So you can click from the frames that we have uploaded. I'll be clicking on the latest frame. So this was the same data from the dashboard, which is displayed in a structured table. Each row lists the product name, the predicted quantity, the model confidence level, and its stock status. At the bottom of the page will be the actual snapshot of the analysis for the frame itself. So this is the current frame, and we can go back and choose another frame, for example, frame number 8. And again, it will show the stock level for that specific frame. And at the bottom will be the analysis result for frame number 8. This user stories demonstrates the core functionalities of the AI stock level estimation system, from image upload to AI analysis and data exploration. Together, they show how the system simplifies stock monitoring and improves decision-making in the supermarket. Thank you for watching, and now I'll pass back the time to my group members who will be continuing the presentation.
Okay, let's see the end of our user story and the functionalities of our stock level estimation system. And we will get back to Tanvi to do some limitation of our project.
Now, for this part, I'll talk about the limitations on the project. Before we talk about scale, I want to be upfront about what currently limits the system and how we're addressing it. For the data and generalization, because our training data is still small, the model is strongest on screen, as you have seen before. In the new stores or unusual lighting, accuracy can dip, so growing a proper image result database is a priority. For accuracy risks, monoclear depth can struggle with occultations and angle views. Similar looking SKUs or hidden labels can also cause mix-ups. We are reducing this by improving geometry calibration and refining labels so the depth to fill conversion is more reliable. For latency and other operations, very large images slow inference and can push the dashboard beyond a 5-second update, which isn't acceptable for a live view. So we're tuning image sizes, batching, and hardware as part of the deployment. For privacy and compliance, ceiling cameras may capture people as we scale. We'll pair role-based access with strict retention and masking to stay compliant. These are solvable and they directly inform about our next steps. And on to the next slide, I'll talk about the usability testing to make sure that the tech translates into action. We ran a usability survey with our classmates and other people who used our website, and they explored the dashboard, viewing shelf fill percentages, thresholds, and exports, and then left structured feedback on our project. What we learned is that users want the stock status to be instantly legible. They like having CSV export, but want the button easy to find, and they prefer plain language where like they can understand by seeing the result very easily around refill thresholds. We iterated on copy, color, contrast, and the placement of actions so staff can move from different shelves with minimal friction. The takeaway is that while the model is improving, the product is already understandable and usable for non-technical users. And there are some improvements that other people have mentioned about authentication features in the project itself. While we have not integrated them yet, we plan to do so in the future. And on to the next slide. For our sprint milestones, we delivered over 5 2-week sprints, 10 weeks total. The milestones were deliberately staged so value was visible every sprint. For sprint one, we did Figma UI mockups. We locked flows and acceptance criteria with stakeholders, and basically the first week for the first sprint was mostly about UI planning. And for the second sprint was the front-end MVP using Next.js dashboard scaffold ready to ingest the actual data. For the third sprint, we basically did the backend connection using like ASP.NET Gateway and APIs and containerized them using Docker. And for the fourth sprint, we integrated the AI model using SAM2 for segmentation plus Midas for depth, stock fill, and which surfaced in the UI. And for the final sprint, mostly we did the export threshold, some polishing, and mostly documentation of what our project has been throughout the whole 5 sprints. And this cadence gave us the predictable delivery and consistent feedback loops. And for the next slide, for our future plans for the project, we look ahead, and our main focus is on data reliability and day-to-day impact for the store teams for calls. And the picture you saw before brings these together. So for number one, the data and model flywheel. While we will build a database to store shelf images, model outputs, and historical trends, that lets us fine-tune SAM2 plus Midas or train custom models on call-specific layouts, steadily improving the accuracy and category coverage. It also unlocks forecasting and performance dashboards, moving from a single snapshot to trend-level insights. And for second one, infrastructure and deployment, we will host the stack on AWS, front-end gateway and inference behind CI/CD, so improvements ship safely and automatically. With monitoring and a light support model, we get predictable uptime and latency as we add more stores. For the third one, store floor functionality, we will deliver a mobile-friendly view for staffs, mobile or tabs, any smaller device that's easier to carry. For staffs, add authentication and role-based access so managers and team members see the right level of detail and enable real-time low stock notification so action happens in minutes and almost instantly, not at the next walkthrough. So the story is capture data, and then we improve the models, surface the forecasts, deploy safely, trigger fast action. That's basically how we get from today's demo is to a fully deployed, data-driven shelf monitoring system. And our next step is pretty simple. Pilot one aisle, measure fewer stockouts and faster refills, and then scale up. And that's it for my explanations, and I'll pass it to Robin to explain the sprint resolution.
Awesome. Thanks, Tanvir. Now Tanvi has already talked about what we did in our sprints and what we can do in future sprints. I'll now talk about our team's productivity in our sprints so far. So in the slide, we can see the Jira velocity chart. And at a high level, it demonstrates what we completed our tasks on time across all the sprints. The gray bars show the total story points of work at the start of the sprint, and the green bars show the total story points of the work that was completed. And the reason why the green bars are higher is because the story points were changed during the sprint. And in Jira, these changes are reflected in the green bar, but not in the gray bar. And so we can see that excluding sprint 3 and sprint 4, the green bars were higher. Nevertheless, all the tasks were completed on time, and I will demonstrate that in the burn down charts in the next slides. So as we can see in sprint 1, we started with a small manageable commitment of tasks, and that was the reason why we were able to complete all of our work on time and very early. As for sprint 2, our workload increased and we saw story points that were added in mid-sprint, as can be seen by the line going up. But even with the extra work, we still managed to consistently reduce the story points and finish everything by the end of the sprint. Next slide. In sprint 3, there was some delay, but there was still steady progress with better work estimation, which is clear from the fact that there is no increase in the trend line, and we were still able to complete all of our tasks on time. In sprint 4, however, there was a huge delay in getting started, and most progress happened near the end of the sprint. We had a few other priorities outside of this project. A lot of us had assignments in other subjects due that sprint. Some of us had extracurriculars and a hackathon submission due in that sprint as well. But at the end, we still completed all of the work. Next sprint. In our final sprint, it wasn't as bad as sprint 4. Our performance here dropped quite a bit due to university deadlines. And as we can see, there was an increase in the story points as well. But even with the slower burn down rate, the team still completed all the work on time. Next sprint. Sorry, next slide. This was a collaborative project split across multiple repositories on GitHub, and we worked with pull requests, code reviews, and CI/CD. So for our CI/CD pipeline, we implemented some automated processes to make sure that code quality is maintained. This included automated linting to ensure consistent code standards, as well as code formatting and build checks that run automatically with every pull request so that we can quickly identify errors and maintain a clean and functional code base throughout the project. We also experimented with configurations on Vercel as part of the workflow, but we encountered some deployment errors. And since deployment through Vercel wasn't part of the scope of the project, we decided to abandon it. Now I'll pass it to my friend Hui, who will do the live demo of the project.
Okay, so and now I'm going to go to the live demo. As I said before, we are building the image, and while you're doing the image, we're doing the presentation. And now we get back to the image again. Let's see, is it finished? As you can see now, all the image is finished at the moment. You can see it now. And now you will go to the localhost to see the front end to how the website look like. Wow, this is the completely fully built image from our project. So it will include the home page, the upload page, and the dashboard. And we also doing some improvement by using the responsive design as well, and also implement in dark mode or light mode. I will test you guys with the dark mode. So this is how dark mode going for our page. So at first we gotta use when you use the page, we will click get start and we move you to the upload image. And this dashboard currently you doesn't have any data, you doesn't upload any image, so there's no dashboard display. Now I will get back to our light mode to make easier visibility. So I'm gonna test our page. So I will get the data from our dataset and select the first camera to test it. So I will test with maybe 5 images this time. And then yeah, everything ready to upload. You can adjust the camera and adjust the image if you want to, and you can review the image to see how it's going, and then you can select each image. And yeah, while you're waiting for uploading, it will be running the AI model behind it. This is the way how the front end connect to the back end. Okay, it's already done for the image. It will show the result for how many items it's gonna be detected and how each product status like. And I'm gonna do all function, the upload all. So it will run every image every single time by using the AI model. It will do detection for each. As you can see, it's still running the AI model. After you finish, it will show you the dashboard button. It's still loading for our AI model. Just wait for it. Okay, so now since every image has been uploaded successfully and the AI model already run behind it, I'm gonna view the dashboard at the moment. So as you can see, this is our result from the latest image. It's gonna be, if you apply it into the real time, it's gonna be the latest time, like the latest frame. It's gonna crop from our camera. But since now project is just the manually uploading, so it's gonna display the latest image, the last image you upload. And if you want to view the dashboard, just click one product you want to view to see how it's going. So in this status, you're gonna have the line path for this product for each frame number, and you can also adjust any image, any type product you want. So this one will be present for the first image you upload, and when you apply to the real time, it's gonna be 15 image per capture. So it will be 15 minutes, like 22 hours something, but it will be different between 15 minutes. If you want to select all, just select all, and our visualization will be able for you. And if you don't want to view anything, just click on. I will do some symbol for the save function. So uh, I want to save it as PNG file, and then you view it. There you go. Our result for the image for our dashboard. If you want to view specifically for each frame for each time, just go to table view. It will be include all the view, all the frame. It will do the detection for each frame. It will save into table view. You can view the first frame by look at each product and see how the confidence, the status, the stock level, and also the output image of our segmentation for easy to visualize and for the staff to check if the detection is correct or not, the notification correct. And it also have the frame, the last frame, which is the current frame. Yep, like you saw before. Yep, the other frame. That's and I think that's basically everything. And if you want to restart everything, just click get start and everything will be restart and you do it again. I think this is the end of our live demo, and we are still targeting to expand our project. But basically, now our target project is just that. And now we get back to Robin to continue our presentation.
Awesome. So now let's wrap things up. The goal of this project is to make intelligent, automated shelf monitoring available for a supermarket. And we want to make sure that we build a solution that is accurate, efficient, and powered by real-time data, because stores today still heavily rely on manual self-checks, leading to delays, inefficient labor use, and costly stockouts. Next slide. Here are our other resources, including the Figma design, the brochure, the poster, and the links to the GitHub repositories as well. We also have a QR code for the GitHub repository and for our pre-recorded presentation, if you want to take a look at that. That's pretty much it. Thanks for attending.
Thank you.